Hello everyone. Don't worry, we will look at some Rust code later on in this video, but I just wanted to go through this first because I thought it was really interesting. I don't know about you, but occasionally you slip into the bad habit of getting ChatGPT or Claude to fix your code, and then kind of you're so pleased that it's working, you forget to go back and actually understand what you've done. So this is a message to myself and to everybody not to become too reliant on AI. So it's partly a confession, but it's also, I don't know if you can see these bits of paper. So pen and paper, or so that's me writing out code. If I write it out and I kind of keep it on my chair and I look at it once or twice a day, that's a good way to learn. Books, Kindle, right? That's how I learn Rust. Well, also, and asking ChatGPT or Claude. But let's just read this to start with. In software engineering, over-reliance on LLMs accelerates incompetence. LLMs can replace human critical thinking, i.e. problem solving. The text in this essay was written without any use of AI. If you looked at my website, you'll know I've got quite a lot of AI sort of generated images, and some of the content is AI generated. So yeah, I consider myself told off. IQ drops with LLM dependence. Possibly if you're younger, but if you're kind of 30, 40, 50, hopefully you've got enough inbuilt knowledge that the LLM's not really going to be quite so bad. Speculative inverse correlation between LLM dependence and IQ. By now, much ink is dried on the way. I'm not going to read all this, but I don't think anyone believes that a computer program is literally their companion. Some might. So engineers who view LLMs as an ally invariably prioritize or feel pressurized to prioritize velocity. For them, production trumps perspicacity. Yeah, so it's the pressure of having to build something quickly. While it's true that LLMs can deliver a lot of code quickly, their use carries a long tail. Yeah, so technical debt. Having said that, I have written code where I've just dumped everything in main.rs and then asked the LLM to refactor it for me to smaller files. I think that's been quite instructive. But obviously, you still need to learn. You need to study how it's broken stuff up. For instance, if it's making you a directory for utils, handlers, connectors, database, whatever, you need to study how it structured it and then learn from that. Don't just say, "Oh, that's nice," and then next time ask it to do it again for you. Output risk. Yeah, we know blatant hallucination, all that. Input risk. LLM doesn't challenge a prompt which is leading or whose assumptions are flawed. Yeah, so if you ask it a stupid question, you get a stupid answer. Yeah. Future velocity. Yep, so technical debt. User infantilization and extinction of talent will occur within individuals and organizations that outsource thinking and problem solving to LLMs. Yeah. I mean, you can get it to help you debug stuff, or you could get it to kind of just, it's like a second opinion, but senior engineers are deprived of the opportunity to learn through productive struggle. Their existing problem solving and critical thinking skills atrophy. Yeah, so junior engineers never develop such skills to begin with, and so can never in turn mentor future junior engineers. Yeah, so loss of joy. Yeah, so I don't know about you, but if you've ever stayed up till sort of 2 a.m. trying to get something working and then eventually do get it working, that's pretty satisfying. But if AI does it for you in 10 seconds, then not so satisfying. I'll become redundant. Well, you will become redundant if you can only do what an LLM is capable of. So I've been thinking about this a lot, and obviously it's your domain expertise. So if you come from medical, data science, creative, network engineer, whatever background, but you need to kind of intertwine that with your programming knowledge and also your, should we say, leverage of an LLM. I'll state the topic with deferred to future post, blah, blah, blah. So this is from 1985. It talk about Team A and Team B in a room, each in a separate room playing chess, and then they say which one will deliver. So Team A is tasked to write a program. Team B just waits and plays chess. So who will deliver the better solution? Team A, because they wrote some code. So think about it. Right, I'm going to skip to the conclusion. We found the wisdom for the LLM age by remembering what two forerunners of our discipline had to say about software design and complexity. If you're a skilled, experienced engineer and you fear that AI will make you unemployable, adopt a more nuanced view. LLMs can't replace human engineering. The AI hype cycle will eventually peak. Oh, that's interesting. Let's look at that then. Let's see. It's going to be sort of, is it the S-shaped graph? Oh. Some more articles. Oh, number 10, Gartner hype cycle. There we go. So where are we now? We're probably heading up towards the peak. Then we'll have a trough. I'm not so sure, but do you think it was going to drop that much? Trough of disillusionment? Because, I mean, take what it's doing with images. A year or two ago, a beautiful woman would have 6 fingers and 3 legs, but now it's really good. So, image creation, I wouldn't say is trough of disillusionment. Obviously, the video, I don't know, but AI will stick around though, use it as a tool, not a crutch, continuing to invest in the same fundamental engineering skills that were deemed valuable in 2019. Right, okay, I'm going to skip now to some Rust code. We'll look at, as always, this is my habit. Let's look at the cargo.toml first. Always gives you an idea for kind of what you're letting yourself in for. So you've got Tokyo. In fact, this is code generated by Claude, so full disclaimer. And in fact, I wouldn't have done that. I would have done macros and rt multi thread. You don't want to bring in more things than you have to. We got request. I don't know about you, but whenever I add request in Rust, I always just add JSON now because it's not going to add a lot of bloat, but it's going to, most times you need it. And derive as well. Serde features derive. So kind of, always. Serde JSON futures util. So it's going to be some sort of async thing going on. I'm going to show you this code. It's also going to have an API key in it, which I know, don't show your API key in videos. I'll delete it. It's just easier to demo it like this, and then you get the idea. Use request client, as always. Create a client object. Deserialize, fuse futures util stream. So stream. What's the? Okay, right. So I'm not looking at second screen or anything. So everything I talk about here is stuff that I know, and Do you know about the imposter syndrome? So that's where you think you don't know stuff. So kind of I'm talking about this because hopefully you understand that I actually know this stuff or some of it. And that is kind of the proof of the pudding is that you know stuff. So that you know stuff without needing to constantly check it with ChatGPT. So what's the EXT here? So that's extended. So it's kind of extra bits onto Stream. And because we're going to query an LLM, we will be streaming the response. So serialize, that's taking our Rust struct and then serializing it to send, send it as JSON. I always remember that deserialize is converting back to Rust. To serialize is the opposite. Is kind of the other way around to remember it, probably. But a bit like with Cisco, you always remember what with Cisco to turn on an activate a port is no shutdown. It's like no, you put the negative before it. Chat request, model, messages, temperature, top P, max tokens, stream. So these are all fairly self-explanatory. I can't remember what top P is off the top of my head, but that's something I need to go back and learn. So delta, that's going to be some sort of chunk choice. So delta, what is delta? Delta is the content. So okay, stream chunk. So we've got lots of deserialized. So where it's deserialized, that's something that's going to be incoming, and then it's going to be converted to Rust so we can work with it. Tokyo main, so asynchronous. So we're going to expect to see an await somewhere further on. Result, so that's just going to be okay. We're not having anything, not expecting anything back other than okay. If we get an error, we don't know what size the error is going to be, so that's why it needs to be in a box, because we need a smart pointer to the error, which would be on the heap, but we don't know how big it is. Because we don't know how big it is, then we just need to make it say dynamic std error. Client new, so we instantiate the request client. And then we create a request body. So we're going to send in our request, we're going to pass the model, DeepSeek. This is all available to us or to me because I've signed up for an NVIDIA account. And what I did was I picked a model to inspect, and then I got this sample code. It gave me Node, Shell, or Python. So I took the Python code, and then I asked an LLM to write it in Rust. So what you could do is just get the LLM to write it all for you and then run it, and then happy days, and then go to the pub. So what I'm going to do is I'm going to write it all out, unpick it, understand every line, and that's going to be my sort of self-discipline, really, the discipline to the the curve. I think we need to be mindful of this. So I don't want to end up at the bottom right. We need to stay at the top left. Okay, so that's a string. We convert to a string. Messages, so role, content. This is all fairly standard LLM kind of stuff. Obviously, I've hard coded that prompt question there. So temperature, you can change these. These aren't set in stone, and to be honest, this is just kind of these are just variables you can tweak. Stream true, so we want it to stream the response. If you set that to false, then you probably will be staring at a screen for a while with not much happening, because this response, probably 30 seconds, I would say, maybe a minute even. I might just turn off, there we go. Is that neater? Just so we need to, now that we've built our request body, we need to use that with our client. And we're going to send it in here in a minute. So we want to post to this endpoint for the chat completions. We want to pass our API key. Then we want to send the request body as JSON. So for this, then this is kind of a nuance with requests in Rust compared to Python, say. In Python, you just do get with URL inside the brackets. With Rust, you specify your endpoint, you put the body into JSON, but that won't actually do anything until you send it. So yeah, send. Just always remember, if you've come from Python or if you've kind of switched between the two, just remember with request in Rust, you do need to send. And JSON is available to us here because do you remember what we had in Cargo Toml? Good JSON there. And I've quit that, so I need to go back. Right, request body. Let's do ZZ. Right. Another tip: once you start writing bigger bits of code and you're using Vim, just do Control Z and then FG, because you don't have to wait for Rust Analyzer to load again. Yeah. So you await. This is I need to just understand this a bit more clearly. So await, because there's a few you're saying go off and do other stuff if you need to, and then come back and get a result, and then the result you change to a byte stream, and then we handle the bytes stream here, and then we take chunks of it, and then we convert the chunk, which is the byte stream. We create a string UTF-8 lossy, and that can be that's of type cow, so that's clone on write. I still find clone on write. To be honest, I understand theory, but I don't ever use it. So yeah, probably that's one for the notepad. Just go back and just do a couple of clone on write examples. Clone on write basically allows you to return either a string, so on the heap, or a string slice. It gives you sort of flexibility on what you are returning. I always got cow mixed up with asref, but asref allows you to take a reference to another type. So for line in text lines, we are going to check if it starts with data, and if it does, we're going to trim that off and then break. If let OK, passed. Okay, so Saturday JSON from stream. So we're taking basically the JSON, the stream of the JSON, the stream that we get, we're going to convert to JSON. Choices.get. choices, I think, is what that's a key in the response. And yeah, delta content. So that's kind of delta is obviously just the kind of the next bit. Right. A few things to go back and revisit here. So stream chunk, that's available to us because we added this. So if we just comment that out, we should get an error when down here with stream chunk, I would think. Let's try and just run that. I'm hoping the compiler will tell us that we need to add stream. Yeah. There we go. Use features util stream ext. So how many errors does that give us? 5. Wow. Add it back in and it works. Magic. So I just need to. I think probably the best thing to do next would be to kind of. There we go. So that's streaming the response. I need to explain trait bounds. So the question we asked was explain trait bounds in Rust, and it's streaming the response there on the left-hand side. You can see. There you go. You see, if I move the mouse, there we go. So it's still going. Without that, so let's just quickly change that to not stream. Let's just. I rarely come in and experiment enough, I would say. So let's do some experimentation. And again, I mean, this channel's more about learning Rust, but I think we can't live in a bubble and pretend that AI doesn't exist. So you can see this is running, but it's making without the streaming, you're just staring at a black screen. So not ideal. This is running. This is so. NVIDIA have lots of models you can try, and they obviously give you the trial code in Python, Node, or Shell, Bash. You generate the API. So even if you're a Rust station, I would say just get that code. Ask Claude to convert it for you, or convert it yourself. I think now I've seen the structure of what it's doing. It's using requests, Tokio. It's using starts with, so it's removing the start of the response, and then it's streaming the chunks back as bytes, and then you're converting the bytes to string UTF-8 lossy, which is the delta. Well, that's what it's doing when you've got stream set to true. When it's set to false, then you end up with this. So yeah, what do you think? Do you think that I think it's probably slightly age dependent. Will younger people grow up being worse programmers because they just use Cursor or Claude or whatever for all their coding? Maybe they might get more into best practices because they refactor everything, and I don't know. I guess there we go. So that actually didn't print anything. There we go. So that was a bit of an anticlimax. Apologies for that. So because it's only here we go because this So all we've here is streaming the chunks, but if we don't stream it, then we don't see anything. So this is a good one to mess it to experiment with, is the temperature. Let's change the question as well. So explain osmosis. I don't know why I said that, but that should give us, hopefully that'll give us a shorter answer. And think. So that's with the temperature of 0.2. Quite a detailed answer. I think that's because we got the max token set to. Oh wow! Did you see that? That's so cool. It's got a little wave icon in the microscope. I don't know. I probably shouldn't be so impressed by that, but I think it's neat. Right, let's experiment with. Let's change max tokens to 1024. See what we get here. We got a plant and a raindrop at the end. Okay, so I think that was that's max tokens of the input, wasn't it? Let's change. Let's change it to a really small number. Not even that. Let's do 18. Let's see what error we get, because we should get an error, I think. I know, because the question's so small. You see, there we get a much shorter answer, though. So osmosis is the movement of water molecules across a semi-permeable. That's the end of it. So that was 18 tokens, but obviously it's more than that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 11 words. So yeah. This is not an AI tutorial by a long way. This is just me experimenting now. So let's change that back to 496. That was what was that before? 0.6 was it? So we've used DeepSeek here. So you can go on to, well, obviously you can put in whatever model you want within reason. You need a text model to get back text. Could I type this from scratch, or is AI lowering my IQ? Let's consider. I think probably the streaming chunking part I understand, but I wouldn't have known how to write it. Not from scratch. Or not coming to it fresh, obviously with the kind of yeah, a little bit of a refresher or a little bit of reading you probably could have got there. But yeah, so the byte stream, I probably would have forgotten to do that. So yeah, I would say it's all there, but apart from the streaming aspect. But once you've done it once or twice, I'm sure it's yeah, it's going to come fairly naturally. So nothing too scary there, really. I mean, it's how many lines? 79. Yeah, 83 lines. Well, I mean, we're not doing the clever stuff here. So the people who wrote the models are the clever people. But this, and again, this isn't really. I guess the fact that it's using async is good, but it's not really For instance, you could have written this in Python and it would probably just have taken basically the same amount of time. But obviously, because it's in Rust, it's compiled, so that can be a benefit. Yeah, the logic here. So you've got a for loop. So let's have a look at the branches here. So you've got if let, if. So you've got if, for, while let. I don't think that's too bad personally, but yeah, it's quite a lot of nested ifs, but you don't have all the else's. So this is a great thing with Rust is the if let, because yeah, you wouldn't be wanting to keep providing else do nothing. Trim start matches. I read that used to be called trim left matches, but in different languages, some languages go from right to left. So they changed it to start so that depending on your language, it trims the start. So if your language goes right to left, it trims the rightmost part, if that makes sense. Next, that was one with that when I started first learning iterators in Rust, I never really understood next because I thought, well, I want to access the first element. But if you do next, it obviously does because you start from the start of the iterator. So yeah, I was looking for like res.first, but you don't need it because you start with res next because it starts at the start. I know what I mean. Yeah, so streaming, I think probably the thing we can learn from this is streaming responses. And yeah, this article. So if you want to read this article, Doug Slater, www.slater.dev. And yeah, just have a think about it. And maybe if you're feeling guilty that you've used LLMs for writing too much code recently, then write it down on paper, turn your laptop off, and you know, even when you're cooking your tea or something, just have a look at your bit of paper. And it's all about the mental model. You got to have a mental model of what you're doing, and if you don't have kind of that in your head, then junior engineers never develop such skills to begin with, so you can never in turn mentor future junior engineers. And if you're a Rust developer and you haven't got a book at least this thick, then shame on you. I mean, the great thing about books is you can read them outdoors. So if it's nice, if it's in the summer and it's hot, take a book outside, read it. You don't want to be indoors looking at a screen. Well, I don't. Not if it's 30 degrees outdoors with no air conditioning. But then that's just me because I live in the UK and we don't have air conditioning. So yeah. What do you think about this graph? Let me know. Thumbs up, all that usual stuff. To be honest, I haven't done quite so many videos recently because I've actually been doing more code, believe it or not. But yeah, use LLMs, but remember this graph, I would say. And this is not me preaching because I'm guilty of it myself. So if you get an LLM to help you with your code, go back and kind of unpick it. And then some days just try not to use an LLM and just write something from scratch. Easier said than done. Thanks for watching. I'll be back soon. Thumbs up and all that.